I'm audible. Okay, great. Okay, guys. So as you can see, today we are here to learn about SolidWorks engineering drawing and BOM. And I'm starting this quick because uh, we have limited time today. We'll able to uh, make this session until 8:40 only. So I hope if you have any questions, doubts, you will ask a little bit quick. So this is basically the day 6 session, and in the last session we had talked about the SolidWorks assembly basics, like how we can assemble multiple parts, what is the exact process to use to bring multiple components in a single assembly. And in this session, that is on day 6, we'll learn how we can prepare a manufacturing drawing, engineering drawing, how we can create BOM, bill of material, using those assemblies inside SolidWorks, because this is the most important part, right? So let's move into the SolidWorks and see. So we are going to open a very simple assembly, very non-standard assembly that we did in the last session. So I will simply, if you want to bring the last file that you had worked inside SolidWorks, and the keyboard shortcut for that is just press R key on your keyboard. And the moment you will press R, you will be able to see all your recent files that you have opened inside SolidWorks. So this was the file that we have worked on the last session. So I will click on it and it will load into my SolidWorks. Very easy, very simple. It will take few seconds because that's an assembly file. So it's quite obvious that it can take few seconds to load, and we will wait for that. As you can see, it's loading. Until now, I hope all of you are going through all the sessions, older sessions, and the recordings we are uploading into the dashboard, because going through the session again and again is important. If you're stuck at any point, any questions, any queries, you can just get back to me on my WhatsApp or in the WhatsApp group. You can text me, you can drop your query, and whenever I will get the time, whenever I have some free time to answer your questions, I am definitely going to answer that. So it's important you ask questions, right? So don't worry about if I'm not answering that instantly. Don't worry about that. I'm not going to answer that. I will definitely answer that, but you have to ask a question. You can also remind me if I have not answered it. You can remind me anytime. So let me launch the SolidWorks again. Somehow it just got crashed. So I have already pasted the link in the SolidWorks. Still people are sending me a personal message to join the session. I don't know why people are doing this anyway. So let me relaunch the SolidWorks. It just crashed somehow. Anyway, so today we are going to learn about creating engineering drawing, and why engineering drawing is important. As I always say, engineering drawing is the main purpose of learning these 3D CAD tools, because if you cannot create the drawings from your 3D models, that is not manufacturable, right? Because on the shop floor, the people who are using machines, who are operating machines, they need drawing. They don't know SolidWorks how to use, so they need drawing on a paper. They need some kind of validation or verification. So you have to share the detailed document as a PDF file, as a detailed drawing to them, so they are able to manufacture your parts, and then it can be used in a place for which it has been designed. So let me launch the file again. Yes, this time it was able to load that assembly file. So here you can see this is the simple assembly file we created, and there is a small thing that we have changed. We have decreased the cylinder diameter, but that is not visible over here. So we'll quickly update this part file inside this assembly. And if you want to update any part file even in the assembly, simply go onto your design tree, make a right click on the part that you want to modify, and then you will get an option that says edit part, right? So click on the edit part, and the moment you will click on the edit part, only the part that you want to modify will be completely visible, whereas the other parts will get converted as a wireframe view kind of type, as you can see over here. This means this part is active, and whatever the change, whatever the operations will do now using all this tool under the feature tab will be applied onto this part only. Now, if you'll expand the design tree, and if you'll go into the first boss extrude we did, this is the sketch we want to modify. We want to decrease the diameter of this pipe. So we'll make a right click and click on edit sketch for this part. And now you can see the diameter right now is 28. So we'll change that to 15. So you can see now the 15 is correct, I think. So I will simply click on finish sketch, And the moment I will click on finish the sketch, you can see the part just got updated, the size just got updated as per this hole. Now I can click on finish this part as well. Now it is completely matching the size of the hole that we have over here. Now we want this to be inside that hole, and for that we'll go on to the mates and we'll find that mate that we have applied to match this face and this face, and that is this one, this mate, coincident mate we have applied. So we'll simply click on edit this part and we'll change the coincident mate to parallel, and then we'll click on finish. Again we'll click on finish, and then we can drag this part inside the hole. Here you can see like that. So now this hole is just parallel and we can drag it anywhere across the screen. So if you want to learn how we are able to do these things and assemblies, just go and check out the last session that we did. Now since this part is ready, I will simply click on the save first, like save all. I want to save all the parts, even the part that we have modified, that will also get updated, revealed, and save the document. That's it. Now since we have saved the file, now is the time to start converting this assembly file into drawing file. And for that, what we'll do, you just have to go on to this file menu, right? And the moment you will click on that, can you see that option that says make drawing from assembly? Just click on it. And the moment you will click on it, a window will pop up where you have to select your paper size first, like on what paper size you want to prepare your detailed drawing, because we already have 5 different size of standard paper sizes basic, and out of this 5, A3 and A1 are the most used paper sizes in basically engineering drawings and this kind of industries. But normally the paper size that we use into our homes are A4 paper sizes, that is also known as letterhead paper size. But here we'll select A3. We are going to take A3 paper size, or you can also select A1 paper size if you want to make it bigger. But here I will select the A3 paper size. And here you can see that there is the ISO template applied with this particular paper size format. So if you want to change the format, you can click on this browse feature, and from here we have some predefined template file formats provided by Solidworks company, right? Predefined format. But if you want to create some custom one, then always remember whatever, for example, let's say we have this custom file format available, right? It's a DIN A3 file format for some custom company we have created. And if you'll click on open, here you can see that is getting applied. Now you can see even in the previous small preview, the title block is getting updated. So we can choose as per our requirement. If we are working in any company and if they have created some template, standard template for that, then we can use that template as well. But here I will simply select, let's say standard one. So I will simply select A3 ISO, right? A3 ISO. I will click on open, and here you can see the title block just got updated. And you can also create custom size, but we are not going to create custom size because these are only the standard paper sizes available in the market. And if you want to print your drawing, then you have to use any one of them from over here, because A1 printer and A2 A1 and A0 printers are not very commonly available. Those are very expensive printers, but you will be able to find A4 and A3 paper size printers around your market as well. So I will simply select as you can see, I've simply selected the A3 one, and then the template we selected is A3 ISO SLDPRT. I will simply click on OK, and it will load the template file for me. So here you can see my drawing template is ready. Now by default it has applied a title block, that is a standard title block being provided from the Solidworks company. But all the time, if you want to customize this one, you can do that. So let's first learn about how we can bring multiple views of our assemblies into this paper file. That is most important. Then we'll learn about how we can customize this template file inside Solidworks, right? But before I will get started, again, you have to make sure that the dimension, system of units that you are following is always millimeter gram second. And now, even if this file is empty at this moment, if you click on save, it will get saved as a drawing file format. And if you'll remember, I have already explained in the first session that the file extensor for drawing file is SLDDRW. Here you can see this is getting saved as SLDDRW. So I will save this one onto desktop. because I don't want to lose data or the files even if the SolidWorks get crashed. Now you can see we have just saved it, this one, right? And in the design, whenever you are in the drawing space, whenever you're creating 2D drawings, on the left side you will be able to see the design tree, but little bit different. Right here you can see it's in the structure there are different options like seat format and stuff like that. So even if you expand the seat format, you can see inside this seat format we have multiple details like border details, punch table anchor, wheel table anchor, general table anchor, whole details, family tables, wheel of material. So we have all these options under this seat format, so don't worry about that. So the first task is to bring the view of our assembly for which we had started this drawing, and that file, that assembly file, was the bench wise. And here you can see, if we'll go back to our SolidWorks, so this is the assembly we have used to convert as a drawing. So we have gone over here and we clicked on the make drawing from the assembly, and then we have defined the right size for our right paper size for to create the drawings for our assembly. Now the moment you are here in the drawing tab, in the first drawing tool panel, can you see the first tool that says model views, right? So you have to click on this model view, and the moment you will click on this model view tab, here you can see you just have to click on over here, right? And then okay, so it is okay. So what you can do, you just have to go to the right side of your screen, and can you see this small tab that is hidden onto the right side of your screen? And in the third option, can you see this view palettes? Just click on it, and the moment you will click on view palette, you will be able to see for your assembly here all types or views are already projected. For example, right view, bottom view, front view, top view, back view. So whatever views are possible for your assembly, all these views are possible. So let's say first I want to bring a front view, so I will simply drag it and place it onto my paper, right? And SolidWorks is so intelligent, automatically it has considered the right size, right scale for this assembly view. And here you can see, if the moment I inserted that, my cursor is still active with that particular tool, and if we'll move my cursor towards the bottom, it will give the projected view of the same front view from the top. So this is the top view. If we'll click on the bottom, it will create another view. If we'll move towards the right and we'll make a click, it will create another view. If we'll move at an angle, it will start creating the isometric view, but I don't want this view, so I will move it somewhere over here. So this view is more clear, so I will click on that. So here you can see tool is still active. What we created 4 different views onto our drawing. What I will do over here now is I will simply press escape from my keyboard, and here you can see. So what I did, I have placed, this is the main view, and with this view all 3 views are attached, whereas this one is not attached. So I can simply drag it and place it onto the empty space wherever I want to, right? Like this. So right now you can see I have, by using this view palette tool, I was able to take any of the view, and by using that view I was able to create the side view and the top view for the same assembly file. And we also created this isometric view, right? And even if you, right now the benefit of it is all these 3 views basically are connected. So if you try to move this one, you can see the other ones are also moving, because these are being projected, these are being connected at this moment into SolidWorks. So that way you can have full control onto the assembly, onto the dimensions that you will be providing into this drawing. But before we'll move on to that, let's first check few more things. So the moment we inserted this one, so this will be known as a parent view, right? And these are the child view. So you can see if I try to move the parent, childs are also moving. Like if we try to move the child, we cannot move it, we can only move it up and bottom, we cannot move it right. And for this we can only move it left and right, we cannot move it top and bottom, because these are the child views and these are always connected with this parent view that is this front view, right? And the moment you will select the front view and if we try to change the properties of the front view, child view will automatically get updated. I will show you how. So first click on the parent view and select it. Now on the left side, can you see it's all of the properties of this view, right? Here is all of the properties. Now if you'll go on to the display state, and here you can see right now the view style for this parent view active is this one, right? You can see it's highlighted. This means this view style is active at this moment, and that is hidden lines removed. If we'll change this to hidden lines visible, and here you can see all the child views are also getting updated with the same scheme, same visual style, right? And let's update this to this one. you can see the rest of the things are also updating because we are updating the parent view over here, right? That's why. And let's go back, let's change this to let's say this one, right? Simple hidden view, wireframe view with hidden edges, right? And if we'll try to change the visual style of the child view, for example, I want to change the visual style of this will not affect the other views because you are only changing the child. So all the time parent, if you make any change into the parent view, every views will get affected. So that's the way. If you want to make a quick changes, you can change in the parent view, but if you want to make some specific changes, you only have to change the child views, right? So what I will do, I will change it back to the default. I will make sure that the use parent style selected, so all the time it is following the parent style. And for this one only, I will change the visual style to this one, right? So now this is looking much better. This drawing is looking much better, but still it doesn't have any dimensions. Okay, so Sudeil is asking also assembly assemble drawing. I'm not getting questions. Anyway, so I will select the parent view, and onto the left side, can you see this next option that says seat scale, right? So right now into this seat, for this A3 seat, we are following a scale of whatever the seat scale is, right? And where I can find the seat scale. So if you'll go into the title block, can you see the seat scale is already defined as 1:1, and from where we can change this scale. So to change the scale, what you have to do is go to your design browser, and you just have to make a right click onto the seat and then go on to the properties. And we'll go into the properties. Can you see the scale for this seat is already defined 1:1, right? And that's why for this drawing also the scale is 1:1. And if we'll change this to, let's say, 2:1, and the moment it will change, if you click on apply changes, and here you can see scale of each views are changing, right? Each views scale are changing because we had updated the scale of the seat itself, right? So that's not correct. I think this scale is not good. So we'll go back again onto our seat, and we'll make a right click. We'll go onto the properties. We'll change back again to 1:1 because 1:1 seat scale is applying best into this drawing, as you can see. So that way you can control the scale of your seat, the visual. These are all the projected view of your assembly file. So if you want to change the scale for these ones, you have to change the scale of the complete seat, right? You don't have to change. You can also change the scale of the individual parts. For example, let's say I want to change the scale of these individual parts. So I will select that. I will go on to the scale, and right now you can see under the scale it is using the parent scale. This means the seat scale of the seat. But I want to use the custom one. I want to change the scale for this. So I can activate this option, use custom scale, and then under this I can change the scale. Let's write it 1:2. You can see this became smaller, or 2:1. So you can play with the scale that works best for you. Let's try 3:2, and you can see 3:2 is working, I think, good for us, but not it's a little bit bigger, so we'll make it 2:3. I think 2:3 must work. Yes, 2:3 is working. So we'll place it somewhere over here near to the bottom. So that way you can also change the custom scale for any of the views. Even you can do for this part, just select it and activate this custom scale. Then you will be able to change the scale. But if you want to update the scale for the whole seat, the process is again the same. Go to the seat, make a right click, go onto the properties panel, and from here you can change these scales, and it will affect, and it will get affected and applied onto the complete seat. So here you can see we have just changed the scale. Now the next part, the moment we have just inserted these views, the next thing is to insert some text at the bottom of it. So I will be able to annotate, like, this is the front view, this is the top view, this is the side view. And for that, what we can do, we can simply go on to this annotation panel, and the moment you are inside annotation panel, you can see this tool that says note, right? So just activate this tool note, and then you can see the text box is active with my cursor. I can place it, click it anywhere where I want to place my view. I will give it some name. Let's write it top, not top, sorry, front view. I will give this view as a name, front view. So how will you define that which one is front view, which one is top view, and which one is left view? So that depends upon the angle of projection that you are following for this particular drawing. But as you can see in the title block, I had not defined any kind of angle of projection. That's why I'm free to take any view as a front view, top view, or side view. But if you're following any particular angle of projection, like third angle projection or first angle projection, then you have to place your views accordingly as per the standard of the angle of projection that you have considered. So you can see we have just placed the first text, that is the front view. Let's again activate the tool and let's place, let's say this one as side view, right? And again, tool is still activated. I will make this one as top view. Here you can see the moment we place these three texts just below the body, so someone will able to understand that this kind of views it is. Now let's say we also want to add some notes into this drawing, so you can click on this note again and you can place the notes over here. Let's write the first note R in millimeter. So these kind of notes, any specific notes, any manufacturing notes, if you want to place, you can place anywhere around your drawing, anywhere around your this drawing space using this note tool, right? Very simple. Now let's start adding some dimensions. So let's say, since this is an assembly file, as you know, it consists of multiple parts. So the first thing that we want to include into is this BOM, like bill of material, how many parts are there and what are all the parts name. And for that, what we can do, we can simply go onto this table section, and here if you'll find, you can see this bill of material section, right? So simply click on this one, and then you can see the tool is active. Now you have to define the drawing for which you want to create your BOM. So I will click on this drawing, and here you can see, and the moment I will click on finish, here is my BOM attached with my cursor, so I can place it anywhere onto the corner. So as you can see, for this particular assembly, for this particular drawing, there are three main parts, and that is the main body, holder, and the cylinder pipe. And it also have the information like quantity and description, so that way you can insert the BOM inside your drawing. And this BOM is again customizable. If you want to change, for example, here you can see the bill of material just got added into your design tree as well. So if you want to make any changes to this one, just make a right click, and then you have to click on okay, so if you want to make a change, there is another way. But if you want to export this sheet as an Excel file, what you can do, you can make a right click and click on save as. And save as, the moment you will click on save as, you can export this file as an Excel file format or the CSV file format. So if your BOM is having more than 100 parts, and if you want to export it and want to share it with the purchase department or some other stakeholders, then you can export that BOM as an Excel file and you can share it with anyone. So that's also possible. Just go into the design tree, make a right click, and then you will be able to save as the file as you want, right? And now yes. So now also, if you want to make a, if you want to customize this BOM, here you can see, if you want to customize, before we'll customize this BOM, the most important thing is, like as you can see, there are 3 item numbers defined over here, like 1, 2, 3, right? But we don't know which item number is which one. There is no annotation. And for that, what we can do, first I will click on save to this PC. So to do that, to annotate the numbers, what we'll do, there is a special tool inside SolidWorks, and that says balloons, right? But here, if you'll activate the balloon, you have to assign the balloons to different parts manually. But if you have more than 50 parts, 60 parts, you don't know where the parts are inside the assembly or outside the assembly. In that case, what you can do, you can simply click on auto balloon. That's it. And then select the part and then click on finish. And the moment you will click on auto balloon, you can see on all the parts these balloons just got assigned. And by seeing this balloon, we can estimate like which part is this, which one, right? We can its balloon is coming with an annotation and an arrow that is pointing exactly onto the part. So this part, the main part is the part 1, and then this part is the part 2, and then this part, cylindrical part, is the part 3. And so if you'll share this drawing with someone, they will be able to have an idea like this one is the main body, this one is the holder body, and this one is the cylindrical pipe body, right? So that way you can add balloons to your parts, and that you can even do for the 2D drawing. But the moment we activated this auto balloon, we have selected this view. So if you'll select this view, the same balloon will get applied, but that will not be visible because it only works with the isometric visual style. So this was the isometric view of our drawing. That's why I was able to assign the balloons to this part, right? But if you want to do it manually, you can do it manually as well, but that will take so much time, right? If we have the option to automate that thing, why will I use the manual ballooning option, right? If we want a particular what is exactly the question? If you want a particular component, so based on it, we'll get it into physically. I'm not getting a question. Anyway, so we can do it for single part also, but right now I'm explaining this drawing environment for the assembly, but you can do it for single part also. That's also possible. Don't worry. So here you can see we had placed the balloons onto it. We had added some annotation, and let's move on and add some dimensions. So to add the dimension to your drawing or the view, very simple. Again, you have to move on to the annotation tool panel, and there you have to activate this smart dimension tool. And if you'll expand this one, you can see we have again this same dimension tool that we used to have in sketch tool panel, but this is for the drawings. So if we'll activate the smart dimension tool, and let's say I want to give dimension for this one, so automatically SolidWorks is identifying that this is an extended cylinder over here. That's why it's automatically giving it a diameter instead of number. Here you can see 515, right? Now let's again activate the tool, and let's define from this side to this side. This dimension is 80. Or we can also define from this side to this side. This side is 40. So that way we can start creating dimension. Let's say I want to dimension this circular hole. So we'll activate this smart dimension tool. We'll click on the internal circle, and we'll point it outward and place it. So here you can see that is 510, right? So that way we can keep inserting different dimensions to our different views. So if you have the spoon, if you want to get it real, actually in that case you have to share the step file with the vendor, not the 2D drawings, because creating 2D drawings is not very possible in case of surfacing objects. So they used to share the step file with the vendor, and using that step file, the vendor will able to use CNC and whatever machine they can do that. But in case of spoons or any curve or organic shapes, it's not possible to create drawings like this, because the curves are not really accurate. Most of the times it has random radiuses, random diameter. It depends upon the flow of the curve needed, right? In that case, it's not possible. So right now you can see we have added, and now I also want to assign a center line to this circle over here. So for that, we have the tool that says center mark. Just activate the tool, select your circle, and a center mark will get applied. So that way you can start adding multiple features onto your drawing. Let's say you want to create a center line at the center of this body. So you have to activate the center line tool, and then define this side, and SolidWorks create a center line, and then you can extend it if it is not covering the whole body. So that way you can add multiple features even inside the SolidWorks using these tools. So I added few dimensions only because I just wanted to give you an idea. And the moment you will start defining more stuff, for example, let's activate this smart dimension tool again, and I can just click on this arc. I can drag it outside. It will give it the radius, right? So the radius right now here for this arc is 10. Right? That way you can start defining different features, different measurement of your drawings inside SolidWorks. So let's say I want to add some dimensions over here from here to here. And anytime if you did something wrong here, you can see I did a wrong dimension over here. So I can select it and press delete on my keyboard, and that will be gone, right? So here, let's add the dimension from this side to this side. I want to keep 40, like that. So all the time you have the complete freedom to define any of the thing like this. Here you can see, like that. Now, if you'll see our drawing carefully, we also have a thread over here. Can you see that thread over here? So that thread is actually visible onto this part. This should be visible onto this part. So this is actually that thread. And if you want to assign nodes to your threads, basically not to hole, because holes here you can see we have assigned. So that is not right. This is actually a thread. So I will delete that one. And let's say I want to assign a hole onto this plate, this area, then I can simply click on hole call out feature from over here, and I can click on that hole feature. And the moment I will take it outside, it will give me a through detail, like the hole diameter is 10 and it is going 35 mm deep. I mean, through hole is over here. That's why. So that way it's also possible. That's why I told you, if you have used while modeling this part, if you will use the process of a circle and extrude cut, you will not be getting these details. But once you will use the hole tool to create any hole, you can simply call out that hole details using this simple hole call out feature. That's why, and in that step, I told you to follow that process. Now, since we have inserted almost most of the things into our drawing that is needed, we are not going into the GD&T features, but still, let's say you want to add GD&T features, you can simply activate this tool. And let's say if you want to assign some special GD&T annotation to any of the faces, then you can simply select, let's say I want to make this face completely straight, so I can select that straightness, then the tolerance, and then you can define other values, and once you are done, you can simply click on done. And all the time if you'll select it, you can modify those features, those values from this box. All the time it is available over here. Also, if you double click on it, you can add multiple boxes, like if you want to add some indicator, let's say like this one. So there are so many things that you have to learn inside GD&T stuff, but this way you can define GD&T onto your drawings using this geometric dimensioning and tolerancing feature. Also, you can define the datum feature on your part. Let's say you want to start machining from this face. This is the face from where you want to start machining, so you can define this one as a datum. So simply activate this datum tool, select the face, and then this face will be act as a datum A. So in your drawing or in your any part, there could be a multiple datum, but that depends upon what kind of machining process you're going to use to machine your part, what is your machine tolerance, and those things the vendors will able to provide, those who will machine your part, right? So that way you can start adding feature. And now before we move forward, if you want to add more features to this bill of material, you can see, you just have to select the bill of material, just select it, and the moment you will select it, you will be able to see all the details of your bill of material onto the left side. And from here you can start customizing it, right? So here you can see inside configurations we have multiple options. In the part configurations we have multiple options. Even we can change the snap points for our table. We have all those options over here. And if you'll go to the bottom, we can change the border style, we can change the layers. If you want to make an uppercase or lowercase, it's completely onto us. So we have all that customization options available, right? And okay, so the question is coming, sir, how could you give an explanation on datum feature? I can't, because we have very limited time, and datum is all about GD&T, I mean geometric dimensioning and tolerancing, and that's completely separate industry. If you want to learn geometric dimensioning and tolerancing, you have to join those classes, because I'm only telling you how to use those tools inside SolidWorks. If you want to learn specific about that thing, then you have to learn from those experts. So I will tell you again, just activate the tool. Let's say you want to apply datum onto this face, just select it, drag your cursor onto the side, and since we already have the datum A, by default the datum B just got assigned, because we already have the datum A into our drawing. And now the next feature that we want to learn into this drawing is, let's say if you want to make a section view along this vertical line. So to create a section view, my process is always, first go to the sketch tab, sketch tool panel over here, activate your line tool, and first create a line from where you want to create your section view. So here you can see I created a vertical line into my sketch. Now I will make sure that this line and this line are both are aligned, but it's not aligned. So I can select the end point of this line and then this line, and then I will make it, let's make it I just want this line to be touching to this point, so I can simply drag it and place it right over here. There you can see. So what I did, I had created a line just passing through the center of this circle. Now on this line, if I want to create a section view, what I will do, I will go on to the drawing tab, and in the drawing tab, can you see that says section view, right? And if you'll activate this tool, then okay, so follow the different process. Select the line first, and then go to the drawing tab, activate the section views, and here you can see I can simply click on OK, and it is creating a section. So first place the section. So right now you can see, if you try to move your cursor, you are able to place section only onto the left side or onto the right side. You cannot move your cursor top and bottom. Let's say I want to place it on this empty space, I can't, because I'm not able to move. So to make it freely moving across any space, you have to press Control key on your keyboard, and the moment you will press Control key, then you can see you can freely move your new section view that you are creating. So I will click, and you can see the section A just got created. Now you can click on this section view, you can select this section view that you just created. So I will just select the new section view, and then I can drag it, right? Okay, so let me extend this section view a little bit. Right now it's very small. So I will select the section view and will try to extend it. Okay, anyway, because we can't extend it because that section we created using that line tool, that was very small. Let's create different section along this line. So again, I will go into the sketch panel. You will use the line tool, and from here to here, I created a line like this, right? And now I will make sure that the end point of this line and this line, both of them are touching. So we'll apply this collinear constraint. Now I will select the new line that we created. We'll go on to the drawing tab. We'll activate the section view. And here you can see now it's creating the right section view, that is BB. And why it's creating BB? Because A was already there. I will simply press OK. And then I can place this section view anywhere. If I'll press Control key on our keyboard, I can place this anywhere. So let's place it somewhere over here. And now, as you can see, for this section view, the scale is bigger because it's taking more space. So, and right now for this section view also, the scale is 1:1 because the seat scale was 1:1. And I want to change the scale. I want to decrease the scale for this one. So I will simply select this one. I will go to the properties. I will change this to custom. I will make it 2:1. I did it wrong. Again, select it. Maybe 1:2 will work. Not 2:1. 1:2. So 1:2 is working. Okay, yes, 1:2 is working. So here you can see for this section view, we have the scale specified that is different, that is 1:2. Whereas for rest of the drawings, we have a scale of 1:1. So that way, if we'll change space scale for any custom views, the scale will be notified just below it. But for isometric view, that scale will not be modified because this isometric view is not for manufacturing. It's basically to give you an overview idea about the 3D model for which you are creating the drawing. So that way you can create a detailed drawing inside SolidWorks. Now, if you want to export it as a PDF, simply go onto this file menu and then you can click on to save as new. And then the moment you will click on save as new, you have the option to convert it as PDF. So here you can see I can select it as PDF format. Then I can define the location where I want to export, and I will click on save, and that just will take few seconds and just got exported as a PDF drawing of our SolidWorks. So here you can see this was the very quick and very detailed explanation of creating drawings inside SolidWorks for any SolidWorks assembly, and the same process applies with the part as well. Now let me know if you have any questions.